Okay, well, thank you everyone for joining me today for Don't Fear Parallelism. Um, just a little bit of information about myself. Most of this doesn't really much matter, or you can read it in about 5 seconds or so. But really, what it comes down to is that I'm a former DBA and developer. Been working with SQL Server for quite a while. I love the storage engine. I love talking about T-SQL. Been doing the speaking stuff for a while, and so much fun. I'm so glad to be back at it because I've been taking a little bit of a break lately. So thank you all for having me, and I'm so happy you all were able to join me. My contact information is also at the bottom as well. You can hit me up on Twitter and email and all that other kind of good stuff. All right, but this is a lightning talk, so let's get on with it. So have you ever, touched a hot stove or touched something like a hot pot on the hot stove and burned yourself? Hopefully you learned a lesson from it. Sometimes you may, the lesson though you may have learned may not be the best lesson. Sometimes you might take it a little bit to an extreme, like I'm never going to touch that hot stove ever again. Well, obviously that's not really that reasonable or feasible, right? We got to keep cooking our food. Instead I should be have used a oven mitt of some sort to protect my hand, as opposed to never touching the hot stove again. I don't want to make that kind of extreme sort of decision and reaction after having a bad experience with something. Well, just like it goes with cooking and how we should not have extreme sort of responses after something bad happens, sometimes we also have the same thing that happens within SQL Server. Many of us DBA types and operational types have had situations where maybe we're told by a sysadmin that SQL Server is burning down all of the cores. We are maxing out the server completely. All CPU is running at 100%. Every single core is being burned down. And when after the fact you do your root cause analysis, you wind up finding out it was just one really, really nasty query that wound up taking out all of the cores because it went parallel freely. So unfortunately, sometimes we have that kind of extreme response of never again. No more parallelism is ever going to be allowed ever again in any of our SQL servers and any of our code. We must now use max stop 1. I don't know about you guys, but I've had these mandates come down from on high from people who are not SQL Server practitioners. They just want to, understandably so, make sure that you avoid a production outage or nasty scenario like this ever again. So again, they take things to another extreme and say, all right, fine, we got burned by it once, never again. But just like, using the stovetop and cooking, we can't really quite stop cooking for ourselves ever again, right? We need to better understand why these things happen. And, going back to parallelism, I like to say that, if you have a better understanding of the storage engine, why parallelism, how parallelism works, why it does what it does, that can give us a better understanding so that, again, we can kind of deal with it in the future on a more appropriate basis. So let's talk a little bit about how parallelism actually works. And if you know me and my presentation style, you'll know that I love analogies. So I'm going to have us take a deck of playing cards, and we need to find and sort all of the spades in this deck of playing cards, right? Now, I could do this work myself, but, I have a bunch of different friends online right now, right? So, and I'm happy to see some names that I recognize here in this room. So I want to share this work. So I'm going to ask some of y'all to help me out here. So I'm going to split this deck into 4 different piles. And then I'm going to ask each one of you to take a pile of cards, the ones that I've handed to you, and find the spades and sort them. So you're going to do that for me because you're all really nice, friendly, wonderful people. Now, once you've done that, you still need to hand each of your individual stack of spades back to me. And then because part of our task is to sort all these guys, I still must resort all of them together in order to come up with the final result, as you can see up at the top here. So, you guys are able to help me out, but I still had to do a little bit of extra work on the back end. And that's essentially what happens with parallelism. I'm able to ask for help, but as a result, I must do a little bit of extra work. And in this case, with just a single deck of cards, would it have just been faster if I sifted through the cards myself and found all of the spades and then just did the sorting? There's only 52 cards in a single deck of cards. This is really, not that large of a task. Now, on the other hand, if I had, say, 10, 20, or 100 decks of playing cards, that's a whole heck of a lot more. Maybe at that point, yeah, it would be faster for me to get the help of my friends, as opposed to just, a single deck of cards where, you know what, it's kind of faster for me to do it just all by myself, rather than having to take those, those 4 additional piles that each one of you come up with and kind of having to resort that final result set, right? So think of it in that way. It's like I have to do that extra bit of work at the back end, or again, would it just been faster for me to do this all alone? So just like many things in SQL Server, going parallel can have some trade-offs. There are times when you really want to go parallel, like if I have many playing cards, and there's other times when you probably shouldn't bother going parallel because of that little bit of extra work on the back end, right? So to help you control parallelism within SQL Server, there are 2 fundamental settings. One is called MaxStop, which controls the number of cores that are available to a given query, or similarly, back to the analogy, how many of my friends can I call upon to ask for help? And then cost for parallelism. Think of it as the number of cards in a given deck before I'm like, you know what, it's just easier if I just do this serial, or you know what, at this point, I'm going to consider going parallel, right? How many cards do I happen to have? And one thing that is almost universally agreed upon is that the default settings for these 2 values in SQL Server are pretty terrible. And those default values happen to be 5, which is a cost threshold, which is very low. Meaning that, like if I go back to that playing card analogy, if I have maybe as few as like 10 cards in my deck, I will still consider going parallel. But I mean, with 10 measly cards, it's a heck of a lot easier just for me to, do that little sorting thing. So you should probably set that threshold a bit higher than that default. And then maximum degrees of parallelism. There's 5 people, there's 30 people, however many people I happen to have in the room, right? Well, the default of 0 allows me to leverage everyone in the room. But what if I'm not the only person who has cards that need to be sorted? What if there are other people running queries, right? And they have their own tasks and they want to come into this room and also ask you guys for help. Wouldn't it be better if I had some kind of discrete limit of, hey, at most I can ask 4 people for help, but there's all these other people that can help out, other people that are coming in here. This helps concurrency, right? So instead of allowing a single requester like myself to consume and monopolize everyone in the room, wouldn't it be better to, find a better balance between that? So I do want to do a quick demo for you guys, and we're going to focus on maximum degrees of parallelism here. And I kind of show you a little bit about how you can kind of see some of this stuff within Management Studio and your execution plans. So I'm going to use my favorite auto dealership demo database, and to show you what is on my SQL Server right now. This particular SQL Server happens to have 4 cores spread across 2 sockets, okay? And it's just a VM. Okay, and my current settings for cost social for parallelism and maximum degrees of parallelism are the defaults, 5 and 0 respectively. I'm going to change these now to maximum degrees of parallelism 3, and I'm also going to increase cost social for parallelism to 150. Ignore that cost social for parallelism value of 150. That's not necessarily a good value that you should be using. I'm only doing that for demo purposes. But I do want to limit the maximum degrees of parallelism to 3, so that at most we can only consume 3 of the 4 cores in this simple example. Now what I'm going to do is I have a query here that is joining from 2 different tables, inventory and sales history, and I have one version that will go parallel, and the second version I have option max.1 to force it to go serial, so that we can do a quick bit of compare and contrast here. I have some cheat sheet notes here for myself as well. So first of all, let's take a quick glance at the respective execution plans. What kind of plan do each of these generate? Well, I can very clearly see in this particular plan, we have some parallelism related operators. Where, for example, I'm distributing the workload amongst my friends, or in this case, different cores. And then I'm regathering, the result sets and the work that you guys did for me. And then I'm having to do a little bit of extra work, right? Think of it in that sense. As opposed to the second execution plan down here, where you don't see any parallelism related operators. And notice that there's different types of operators that are parallelism operators, like distribute streams or gather streams or repartition streams, right? But they all fall under the category of being parallelism operators. Another key indicator that you can kind of see is when you look at one of the different access methods like a clustered index scan here, and I'm going to go over to the properties tab over here on the right. Let me do a, actually, oops, sorry about that. 1, 2, I misclicked it over here. Number of rows read. Notice that in the parallel execution plan, it says thread 1, 2, and 3, a key indicator that, hey, we only use 3 cores per the max stop setting that I happen to have. One of the other interesting little things is that number of executions is a multiplier of the max stop, or again, the number of cores we wound up using. 3 in this case. If I compare and contrast that to the serial plan over here, number of executions against the access method operator, 1. All threads, and all the because again, we didn't share the workload amongst multiple threads, so it's just that single thread consumed all of the different rows. So this is kind of a quick way just to see, whether you happen to have some parallelism occur in one of your given execution plans. The other thing I want to share with you is a really cool bit of code by Jonathan Cahias of SQL Skills. This is something that will allow you to search your plan cache. Be very careful about doing this in production, but it can search your plan cache to help you find execution plans that are stored in your plan cache that went parallel. And you can then evaluate, for example, things like the subtree cost to help you figure out whether your cost structure for parallelism value is a good value or not, and other things like that. And there's more details in the blog post where Jonathan has shared this code. The URL for it is up here, and there's some summary information here that I've also included in this particular script. But being a lightning talk, I don't have so much time, and I've already kind of gone over that time. So let's pivot back and wrap things up. So this particular deck, I do give a fair number of resource URLs and references here. So one for cost social for parallelism, and the other for MaxStop resources. So in either case, this being a lightning talk, we're going to wrap things up, but I will pause and ask if there are any questions. Otherwise, thank you so much. This has been a lot of fun.
Well, I don't see any questions in the chat right now. And we do have a little bit of time. So you were talking about some of your tips and tricks for parallelism, like when it's a problem, when is it not, when should we start looking into some of those things that you're talking about?
So yeah, those are great questions. So, okay, so here's some kind of rules of thumb or things to consider. I like to think of them as parting thoughts, not necessarily best practices, because things can vary and differ between different people, but there are some different. Come on, let's go back. There are some different settings depending on what it is that you want to do, as far as, for example, setting an appropriate max stop value. Part of it has to do with the physical configuration of your SQL server, whether your server is NUMA-aware or not. The bonus URL down at the bottom actually has some additional information if your SQL server happens to be virtualized, because that actually plays a big impact on things. A lot of folks don't necessarily think beyond the virtualization layer, but I argue that many DBAs should. In my current role, working with monitoring software and whatnot, I've come to have a much greater appreciation of understanding what's going on the host level as opposed to what's just going on in the virtual machine. So again, there's a lot of different things that you should take into consideration beyond just what you can see in the virtual on the VM itself. And then coming back to cost social for parallelism, everything is a little bit of a trade-off, because if a query goes parallel, there's a little bit of extra work that must be done to, again, kind of gather the work back together from all of your different friends, right? So if there's if there's only a tiny amount of that, it's one of those things where, yeah, it may be a minuscule value, it may be a minuscule kind of trivial time slice. But the other thing to consider, and this is something I didn't really touch upon in the context of the lightning talk, but I'll bring it up here, is that you really need to also think about your queries at scale in volume. A lot of us happen to have that select statement that runs in a fraction of a second. So, hey, it's really fast. Who really cares? But your application and your workload and your users wind up running it a bazillion times an hour or something like that. So it all adds up really fast. That's one of the other reasons why we don't want those really cheap queries to be just a little bit more expensive, because again, it's something that adds up really fast. Do I want those guys going parallel? And it's also going to cause concurrency problems, because hey, that really fast query that when parallel and consumed 4 cores instead of 1 is now going to be fighting with all of the other guys that are, super fast, super cheap, but they all want 4 cores because they all decided to go parallel. Wouldn't it be faster for concurrency perspective for just to force them to all be serial? The execution differential is going to be pretty trivial, right? So it's really at those fast, cheaper queries that we want to actually potentially not bother with parallelism because they're already pretty cheap as is. So we're not going to gain the benefit as opposed to if I had a huge volume of data and I really wanted to spread that workload amongst my friends and have them help me out. So I hope that kind of helps kind of dissect and explain why you want to consider, whether you actually want to go parallel or not.
No, that's great. And one of the comments from the chat, Hugo says he loves the playing cards, friends in the room analogy. He thinks it works really well.
Oh, thank you so much, Hugo. And it's good to hear from you again, and do miss you.
Again, there are friends in the room.
Yes.
So any other questions that people may have?